and good afternoon my dear kids. Welcome back once again to this short tutorial video for class 8 students. And since I hope you kids have gone through the previous video as well, since we have started the quadrilaterals section, so in this video actually will be a theoretical part. Okay, so what I want you to do is I want you to note down all the points given in the video as well. Okay, and since we have started the quadrilateral section, so in this video we'll be dealing with if you after finishing up this video, I hope that you will be able to get to know the different types of quadrilaterals. Okay, because since we have started quadrilaterals as you know is a four-sided geometrical figure, and there may be several different types of quadrilaterals, isn't it? So okay, in this video what we will be doing is we will be dealing with all the different types of possible quadrilaterals, okay, for possible four-sided figures. Okay, so the first one in here is a parallelogram. So the topic for this one is special types of quadrilaterals. It's given in your book as well, special types of quadrilaterals. Okay, so the first one is parallelogram. So for parallelogram, what do I have is a quadrilateral with each pair of opposite sides parallel. Now see, as I have been repeatedly telling you that the symbol also plays a very important role in your geometry, isn't it? The symbol plays. So see, two arrows here. See, two arrows on this line and two arrows on this line. That means these two arrows means these two lines are parallel. That is, AB is parallel to CD. Okay, and this see one of the lines. That means this line, that is AD, is parallel to BC. Okay, we cannot call CD and BC parallel, isn't it? Because see, they are already intersecting here, isn't it? So these two lines are parallel and these two lines are parallel. So that is the symbol for that. Okay, the arrow is the symbol for that. And similarly, see, with the arrow, what we can see is we can see small cut marks on the sides as well. So I hope that you understood what does that means. So this cut mark means the sides are also equal, isn't it? So AB is equals to CD, and see, two cut marks here and two cut marks here as well. So BC, that means BC is equals to AD. Now see, what was the definition for quadrilateral? A quadrilateral with each pair of opposite sides parallel. Each pair of opposite sides parallel, parallelogram. Remember the name as well. Okay, that's very important. Parallelogram, what is a parallelogram? It's a type of quadrilateral which each pair of opposite sides are parallel. Now, what makes it special and why is it given the name parallelogram is because it's of properties. See, opposite sides are equal as well. Not just they are parallel, but opposite sides are equal as well. Okay, opposite sides are equal as well. So that is why I just said about the marks, isn't it? And opposite angles are also equal. Since I have drawn diagonals in here, so I haven't made an arc to represent the angle. Okay, but you know that opposite angles means what? So this angle, isn't it simple? So this angle will be equal to this angle in here, and this angle, opposite angles. So see, for angles also I have marked different arcs. See, one arc, opposite angles, they will be equal. Two arcs, opposite angles are equal, isn't it? That was the property, opposite angles are equal, and the diagonals, they bisect each other. Now recall the term bisect. What does bisect mean? It means it divides into two equal halves, isn't it? So that means OA will be equal to OC and OD will be equal to OB. Okay, the diagonals, they bisect each other. I guess you know that what does the term diagonal means, isn't it? We have I have already told you about diagonal in the previous video, isn't it? The line segment joining two non-consecutive sides. So this is all what happens in a parallelogram. Okay, that makes it special, and that is why it has got its name as a parallelogram. Okay, why? Because opposite sides are parallel, opposite sides are equal, opposite angles are equal, and the diagonals bisect each other. Okay. Now the next type of parallelogram is a rectangle. See, now rectangle. A rectangle is a parallelogram with four right angles. Rectangle is a parallelogram with four right. Now see, this has been said that it's a parallelogram but with four right angles. Now see, what is the difference between these two figure? See, opposite sides parallel, opposite sides parallel, opposite sides parallel, opposite sides parallel, opposite sides equal, opposite sides equal. See, opposite sides equal. Opposite, we can call opposite angles also as equal. See, isn't it? Opposite angles are also equal. But here, what makes it so special that it got its name as a rectangle is because of its angle. See, here not just opposite angles but all the four angles are equal in a rectangle. See, even though it shows all the properties of a parallelogram, but what is the difference between a parallelogram and a rectangle? See, a parallelogram, in a parallelogram, just the opposite angles were equal. Remember, just the opposite angles were equal, and we haven't been told anything about the measure of the angle, isn't it? But in a rectangle, all the four angles are equal, and they are right angles. See, that means they are 90 degree, isn't it? So the properties will be similar. See, opposite sides are equal, opposite angles are equal, diagonals bisect each other. Diagonals bisect, they also, because as has been already said, it's a parallelogram, isn't it? So it will exhibit all the properties of a parallelogram. The diagonals, they also bisect each other. I haven't drawn diagonals in here. Okay, the diagonals, they also bisect each other. But what makes it special, so special that it got its name, unique name as rectangle, is because of its angles. All the four angles are equal, and all the four angles is equals to 90 degree. Okay, this is how you need to differentiate between two quadrilaterals. Okay. Now the next one is rhombus. So number 3, it's rhombus. So again, a parallelogram with sides of equal length. Now again, see, a parallelogram, that means it will exhibit all the properties of a parallelogram, isn't it? Now what is the unique thing in here is that a parallelogram with sides of equal length. Now see, that is why I have drawn here. See, two arrows, opposite sides. This one arrow, opposite sides. That means opposite sides are parallel. That is what we get to know, isn't it? But see, all the four sides have marked with just one cut. One cut. That means all the four sides are equal in this one. Okay. So what makes it special, and so that it got its name as rhombus, is all the four sides in a rhombus are equal. Okay, remember, till now we haven't got any quadrilateral with all the four sides equal, isn't it? So all the four sides are also equal. So as you can see, the definition, by the definition itself, it has also given its name as parallelogram. So opposite sides are equal. Okay, opposite sides, or we can say all the four sides are equal, isn't it? Opposite angles will be equal. But here we cannot say all the four sides are equal. All the four angles are equal, isn't it? Can we see that? No, we cannot say that, because we haven't been told anything about the angles. So what we know is simple: opposite angles are equal. Okay, and diagonals bisect each other. Okay, now again, the diagonals, they bisect each other because simple, it is exhibiting all the properties of a parallelogram, isn't it? So the diagonals, they bisect each other. Okay, as I've already told you about the term bisect as well, isn't it? Now also, one extra property is that the diagonals are perpendicular to one another. Now what does perpendicular means? It means you will form a 90 degree angle, isn't it? So that is why, see, I have drawn a diagonal, and in the middle I have formed 90 degrees. See, all the four angles are 90 degrees, because see, once you have drawn here 90, it means the opposite will be 90. These two will linear, again it will also get the measure of this angle will also be 90 degree, and similar vertically opposite, again 90. So that is why I have drawn the 90 degree symbol in the diagonals, intersection point of diagonals. Okay, because it's already been said that the diagonals are perpendicular to one another as well. Okay, I hope you kids understood. See, what you need to differentiate, see, what makes each and every one unique is, that's what you need to know from this video onwards. Okay, see, a parallelogram, opposite sides parallel, opposite sides equal, opposite angles are equal. Rectangle also same thing, opposite sides equal, opposite sides parallel, opposite angles are also equal. But here all the four angles are equal, not just opposite angles. Okay, all the four angles are equal, and all the four angle measures 90 degree. The value is also given, because see, a parallelogram with four right angles, isn't it? Now again, for rhombus, what do we have? We got opposite sides equal, opposite sides parallel, opposite angles equal. Remember, we have nothing been told about the four angles. Opposite angles are equal, and the diagonals bisect each other. Okay, the diagonals bisect each other. Till there, all the properties were common among three, isn't it? Now what unique property, one unique property it has is that the diagonals are perpendicular to one another. Not just the diagonals are perpendicular to one another, but the four sides of a rhombus. The four sides of a rhombus are also equal. Okay. Now the next one we have here is a square. So see, now it's been said a rectangle with sides of equal length. Now again, why is it been said a rectangle? A square, why is it? Because it will show all the properties of a rectangle as well. A rectangle with sides of equal length. Now in a square, all the four sides are also equal. Okay, not just four angles, not just opposite sides are parallel, not just simply the opposite sides are parallel and opposite sides are equal, but all the four sides are equal and all the four angles are also equal. So see, it will show, basically it will show all the properties of a rectangle, and since rectangle was showing all the properties of parallelogram, so generally it will show all the properties of parallelogram as well, all the properties of rectangle. What was the additional property of a rectangle beside parallelogram? What is it that makes a rectangle unique than a parallelogram? What is its angle, isn't it? So here all the four angles are also equal. See the properties, opposite sides are equal, opposite angles are equal, or we can say all the four angles are equal, isn't it? The diagonals bisect one another. Okay, well and fine. The diagonal bisects one another. The diagonals are perpendicular to one another. Again, the diagonals are also perpendicular to one another. Okay, well and fine. Now here, one additional thing is that the diagonals are equal as well. Okay, the diagonals will be equal as well. Also, what makes it unique is all the four sides are equal as well. Okay, now what is the difference between this one and rhombus? See, because see, the rhombus also had all the four sides equal, isn't it? Opposite sides are parallel, opposite sides are equal, but the rhombus didn't had all the four angles equal. Okay, that's what makes it unique, and that is why it got its name. It got its name as a square. Okay. Now the next one we have here is a trapezium. Now for a trapezium, a quadrilateral with one pair of opposite sides parallel. Now see, because of a four-sided figure, you may get, as I've already said, any four-sided figure can be called as trapezium, isn't it? So it can be in any form. So what we are trying to figure out is, we are trying to categorize the different possibilities of different four-sided figures. Okay, so one of the possibilities is trapezium. That means a quadrilateral with one pair of opposite sides parallel. So till now, what we got till now is all the opposite sides were parallel, isn't it? But here what we have is, in the trapezium, is just a pair of opposite sides is parallel. Suppose in this figure I have drawn these two sides as parallel, see, and these two, as you can see, they are not parallel, isn't it? Simple. If you extend it, then they will definitely meet up somewhere up here, isn't it? So these two sides, they are parallel sides. So a type of a quadrilateral where just one pair of opposite sides are parallel, that time it's known as a trapezium. Okay. Now in a trapezium, what happens is, a property is one pair of opposite sides are parallel. Now sum of interior angles on same side of transversal. So I guess you might have recalled the paraline and transversal concept from your class 7. From class 7, sum of interior angles, because see, it's a paraline and we can consider this as two lines, paraline, and this line as transversal, because this line is, if you extend it, it will be a transversal. Okay, similarly this parallel line, for this one it will be transversal. Okay, so sum of interior angles on same side of transversal is 180 degree. Sum of interior angles on same side transversal, so these are your interior angles. So see, for D and A, and you cannot just mark with one arc and one arc, isn't it? Because these two are not equal, we know that. So I have just marked it with 1 and 2 arcs. Okay, what we know about this is that when you add these two, you'll get 180 degree. See, sum of interior angles on same side of transversal is 180 degree. Okay, similarly, so now I need to mark with 3 arcs, isn't it? Because I cannot use 1 or 2 arcs, I have already used, so I have used it here 3 arcs, and here I need to use 4 arcs now, isn't it? So that is why I have done here, see, 4 arcs. Now C and B also same side of transversal, interior angles, so the sum will be equal to 180 degree. Okay. So then, now the last type of quadrilateral, that's a kite. Okay. So a quadrilateral with exactly two pairs of equal consecutive sides. A quadrilateral with exactly two pairs of equal consecutive sides. Now you can just simply, by looking at the figure, see figure and the markings on the figure, ABCD is a quadrilateral, isn't it? So what I have done here, see, I have given AB one mark, AD 1 mark. That means AB is equals to AD. BC with 2 marks and CD or DC with 2 marks. So that means this side is also equal. So that is what we have written here. A quadrilateral with exactly two pairs of equal consecutive sides. See, two pairs of equal consecutive sides is known as a kite. Okay, there's anything about parallel lines, so we won't go there. Okay, so it doesn't exhibit any property of a parallelogram. That's what we get to know easily, isn't it? Now, so what are its properties? What makes it unique, and it so that it got its name as kite is the properties. See, the diagonals are perpendicular to one another. Okay, the diagonals, they are perpendicular to one another. See, perpendicular, as I've already said, 190 degree. So 90 degree, not 190, 90 degree, isn't it? So the diagonals, they are perpendicular. So perpendicular. So I have used the symbol for 90 degree on all the four angles. Okay, as I've already told you before, how all the four, if one of the angles is 90, then all the four angles will be 90 degree. Okay, now the second property in here is one of the diagonals bisect the another. Now what does the term bisect means? Bisect means it which divides equally among two equal halves, isn't it? The term bisect means which divides equally among two equal halves. So obviously, just by looking at the figure, you can figure out which two are which two are bisected, isn't it? It's simple. The line DB is bisected. We cannot say AB is bisected because see, this point from here to here and from here to here, how can they be equal? Just by looking at the figure, isn't it? But what we can conclude is that this up to here, from here to perpendicular point, from here to here and from here to B, yes, we can say that these points are equal, isn't it? So because bisect, remember the terms as well, as I've already been telling you. There's a difference between bisect and intersect. Okay, the term plays a very important role. So the term bisect one of the diagonals, bisect the other, that means AC will bisect BD. That means AC will divide BD into two equal halves as well. Okay, so, and remember, this one is a very important one because in the next video we will be doing the sums regarding the variation, sums regarding the types of the quadrilaterals, and at that time the properties will be very useful. Okay, so what I want you to do is please note it down in your copies as well. Okay, and this one is very important. Please try to go through it or mug it up. Okay, please try to remember all the properties as well. Okay, so till then, stay tuned in and for more updates and videos, and stay safe, take care, bye bye.